Section 5.7, problem number 19, we are also solving we're finding the solutions of the triangles. And in this particular case, we're also using the law of sines. So I see that we're given angle A as being 58 degrees, and I'm also given side A with a length of 26, and the last piece of information that I'm given is side B, which has a length of 29. So then, in order to use this formula properly, my numerator should be sine of angle B. Alright, just like before, we want to solve for the letter B. So I multiply both sides by 29. And then I can plug this information into my calculator. I would recommend that you go ahead and take the inverse sine of both sides before plugging it into your calculator, since in this particular case the numbers that you would plug into your calculator would not be very accurate otherwise. So go ahead and type that into your calculator. We've got the inverse sine of 29 times sine of 58 degrees divided by 26. And my calculator gives me that B is then approximately 71.1 degrees. Just like in our previous example, though, sometimes weird things happen. So the first thing we want to do is check and make sure that this is actually an angle that could happen with the given information. Well, we were given that A is 58 degrees. We found that B is about 71 degrees. Those add up to less than 180 degrees. So this angle is possible to give us a solution of a triangle. Now there's one other weird thing that can happen when you're dealing with the law of sines, and that is that there's more than one possible triangle that meets this given information. So let's allow for the possibility that there is a second value of B that would also work. If there is a second value of B that would also work, that can be found by taking 180 degrees minus the first value of B that you're given. So in this particular case, 180 minus 71.1 gives us 108.9 degrees. Is it possible to have an angle in a triangle that's 108.9 degrees at the same time as an angle of 58 degrees? Well, yes, because they add up to less than 180 degrees, that is possible. So this particular triangle has two different solutions. So we're going to track both of those solutions as we finish out the problem. So I found B in both cases. And now what I want to do is, since I know two of my angles, I want to go ahead and find the third angle. So C1 is what I'm going to call this. C1, well, we know that all the angles of a triangle have to add up to 180 degrees. And then I can just subtract off A, which is 58. And since I'm doing C1, that should correspond with angle B1. I'll subtract off 71.1 in this particular case. So 180 minus 58 minus 71.1 gives me that C1 is 50.9 degrees. So that's another piece of the solution for the first triangle. And then the second triangle, we do the same thing, 180 degrees minus the angle that we were given, which is angle A, minus what we found to be the second possible value for angle B. So the second possible value for angle B is 108.9 degrees. So go ahead and do that subtraction, and you'll find that C2 is approximately 13.1 degrees. Alright, so at this point we have two solutions and we found the angles for both of those solutions. Now we just need to find the one remaining side that we weren't given in both of these cases. So side C was not given to us. So we want to use the law of sines once again. So sine of some angle over its opposite equals sine of some other angle over its opposite, and we're really interested in knowing what the value of C1, little c for side C1, is equal to, so we should use angle C1 up in this sine function. So angle C1 is 50.9 degrees. And then on this side of the equation, it's always best if you can use your given information. So in this case, we were given angle A and side A. So let's go ahead and use angle A and side A in this case as well. Go ahead and solve this equation for C1. So you can cross multiply and then divide by the sine of 58, which will end up getting paired with C1. So then you'll find then that C1 is equal to 26 sine of 50.9 degrees over sine of 58 degrees. And then you can plug that into your calculator to approximate the value of side C1. So in this case, when I plug it into my calculator, I find that the value of side C1 is approximately 23.8 units. But we have two triangles here that are possible solutions, so I have to do this same sort of setup in order to find side C2. So once again, let's use angle A and side A, since that was part of our given information. And now we want to figure out what side C2 will be equal to. So we use what we found for angle C2 in our formula. Then, just like above, we solve for C2. So we cross multiply, which will put 26 times sine of 13.1 on one side and sine of 58 degrees times C2 on the other side, but we don't want that sine of 58 hanging with our C2, so we'll divide it over to the opposite side. Then plug that result into your calculator. So in this particular case, we should find that side C2 is approximately 6.9 units in length. So now we have completely found all of the missing angles and sides for this triangle, or in this particular case, two possible triangles that could come from the given information.